Hello, Internet. Today I want to present you a study presented by IEEE about child welfare screening. And you remember I was talking to you about decision intelligence to augment human decision making to make decisions by the machine learning algorithm itself. And I want to give you a use case I found this study some days ago. And this study has opened my eyes, and I want to show you the study. But first, what is the topic? The topic is about child welfare screening. And in the US, you have regional child protective services agencies that are tasked with providing or igniting investigation. And whoever calls, a teacher, a parent, a neighbor, whoever calls, those calls are answered by call screeners, as they are called, welfare specialists. And they decide whether to screen in or to screen out each particular case. So this means they have a binary decision to make. With the information we have, should we investigate this case further or not? So it's a binary decision. This is the complexity of the decision. And to give you some idea about the size we are talking about, where is the data here? More than 1/3 of American children, 1/3, are investigated as potential victims by age 18. More than 1/3 of all American children. So this is a topic that is extremely relevant for us as a society, for mankind. And just to have an idea, in 2018, the authors of these studies note that those CPS agencies in the United States received 4.3 million referrals from concerned parties, like teachers, parents, neighbors, whatever, about this topic. So you have millions and millions of cases you have to decide. And it is interesting that they have about 3 to 5 minutes to decide on a single case. And now, let me introduce you to the title of our study, Decision Making in the Real World Today. Decision making, high-stake decision making, since it's about children, and understanding and addressing the challenges of machine learning in those decision makings. But today we focus on one aspect only, the usability of the prototype. How to design a system, a usability of a system that really supports human decision making. And this is an excellent study from September 17, 2021 to appear in IEEE Transactions on Visualization and Computer Graphics, where they were asked to really use machine learning prediction to support high-stake decisions by human beings. And they're talking about the ethical concerns about oversimplification of complex problems, like a family situation, economic situation, and reduce everything to a single algorithm output parameter. And they did a study that is highly interesting, how to design interactive visualization tool for our machine learning prediction models. And it's independent what model it is in particular, but how can you design something that is of real use to decision makers? And this is not about the financial sector. If you're already rich, how to get ultra rich. This is not it. This is about the weakest individuals in our society and the decisions some people make about their life. And if they ask for support, and you have people machine learning scientists who are trying to help those people, and I think we can learn quite a lot of this. So let's start. We have explainable AI, usability of this system. The child welfare is our topic. Visualization is an important topic. and how to apply machine learning. And here machine learning, again, this is not about deep learning or just general machine learning algorithms. This is about how to design a system that is really usable for decision making, for decision intelligence, able to support humans, or in a later stage, may be able to partly make sub-decisions. This is an extreme sensitive topic. And when I read the study, I didn't want to read the study, but as you can see, the coloring was done by me. I tried to get into this study and understand what we can learn from this. So, topic is machine learning augmentation tools. Again, not the algorithm itself, how we present the results, how we integrate it in the workflow of the humans that are responsible for making decisions. And of course, we've quite a challenge of different things, but let's start with the study. They had 3 stages. First was observation. Observation to understand the existing workflow of the human experts and the challenges they face. Then they did individual interviews to gain additional insights into the desires of end users, what they need, what they wish they would have data. So when they have 3 to 5 minutes to make a decision, which data do they need? How can we construct a visualization of those missing data? And user studies, when they have a prototype with possible machine learning augmentation techniques, and to get a concrete feedback on this specific prototype design. How useful is it really for the work of those screeners? And the topic of child welfare in the US. So let's start. And yeah, design choices, human-centered, explainable machine learning. I think this is clear to us. We are really here are human-centered. We need to understand the machine learning algorithms because it is about trust. When do those screeners trust a prediction by machine learning algorithms? What have we learned from these studies? Explainable machine learning. Humans struggle to use machine learning predictions because they do not understand where those predictions came from. How does the machine work? Why the machine came to this conclusion? Again, explainable machine learning, explainable artificial intelligence as a super term. Let's dive even deeper into this study. And they addressed several user needs. And they deducted usability challenges. The first one, to understand the existing workflow. 5 to 10 minutes are spent on each case. And a large portion of these 5 to 10 minutes of screening time per case is dedicated to determining the factors that are associated with higher and lower risk. And they use the specific risk and protective factors in their analysis. But it is clear, the situation is clear. We have just minutes to make a decision. And if we provide a machine learning algorithm decision, it has to be intuitively clear how the machine came to this conclusion. So, what are the problems that they found? They expressed reservations about using the machine learning model for decision making. What was the general feedback they received at the very first level? And it was lack of trust that the machine learning model provides something sensitive. Humans have the tendency to not consider the model prediction at all when it disagreed with their human intuition. So they looked at the case and they said, well, I think we should go with solution A, and the model tells them solution B. Of course, they disagree and they do not want to consider the model prediction at all. So how to cope with this? If you have human machine learning disagreements, Do you have a clear path forward when this disagreement happens? Because it is interesting. At first, of course, the system has to present how the model worked, why they came up with this conclusion, so that the human can understand somehow the logic. And another problem was unclear prediction target. Confusion how to use the model target, and we don't know about what the score means. What does 15.7 mean? What is the importance of 15.7 as a parameter? So, well, of course, concern about ethics. Yeah, the ethics of using machine learning model score. And they said it could be dangerous for people just to look at the number that is spit out by the machine learning algorithm. Because you, as a human, you are responsible for your decision and you have to take everything into account. And if you just stop thinking and asking yourself, hey, am I really critically thinking, analyzing the situation? And you just say, well, the machine decided. Yeah, there are concerns about ethics here, significant. So first things first, remember, first part was interview the screeners, the human expert on child abuse. What was it that they wanted? What was it what they had addressed in the interviews? 4 points would like to show you. Screeners, those human experts, were confident that they would want to know why the model, the machine learning model, made the prediction it's made. How does it work? What's the logic? Why did they decide in this specific case that the result is B? Why, how, when? Tell me. Screeners believed that understanding how important each factor, how each data point was to the score prediction is more or less a risk assessment below a threshold or under a threshold, would be helpful to understand how important each factor, how each data point, what's the significance of the age of the child, the age of the mother, the familiar situation that they're in, the economic situation, I don't know, where they live, how they live, whatever. And human screeners wanted to know what step the model takes in making predictions. How does the system think that it knows what's going to happen in the future to this child, in this particular family, in this particular economic situation, in this particular part of town that I'm familiar with? Interesting questions. And we as ML coders, we have to have an explainable AI system that provides answers. Because those screeners, if they don't trust you, it is their responsibility and they will be held responsible for their decisions. Now, a very interesting part is about what if scenarios, game theory. What would happen if? And they were interested about information about what could be changed about a particular individuum to reduce his or her risk. What can we do? What can we change? Is there a single fact we can alter? A single situation we can improve so to significantly reduce the risk? Unfortunately, the machine learning model is not trained on causal relationships because the training data is, of course, the old cases of this agency. So explanation would not be able to provide this information that they were interested in. But it is interesting that they look into the scenario portfolio system. They say, hey, what can we change? Where is those particular point in the system where we would be most effective to reduce risk for this individual? An interesting point that the current machine models cannot address. Yeah, this is one of the prototype visualization they came up, and as you can see here, you have the factors that are important for a particular decision. They are described, they're in a category, and then you don't need the values if it's 14.7 or 3.48. You just have a bar chart. And the length of the bar indicates, I don't know, a risk or whatever. And you have red and blue, positive, negative, high risk, low risk, whatever. So you, as a human, you have 3 minutes. You must be able for the input of the data that the system provides to you to immediately grasp all the data that are important for you, for your decision making. And you have to design this prototype, this usability of this prototype, that the screener will accept this machine learning tool to increase, to augment human decisions. Getting feedback on the tools now was the next part. They had the tools, and of course it was a user-centered iterative design process, how they constructed even their very first prototype. And it was, of course, a machine learning augmentation tool to augment the knowledge, the data situation for the human decider, for the human screener of each particular case. Yeah, the motivation behind each interface, addressing its usability challenges, would be a little bit too complicated, but let's go into the feedback. Feedback. What I want to show you is this one. Similar cases. Investigating past cases. This is the only part in this study I do not understand. Because, you know, when we train a machine learning model, we have to provide training data. And of course, the training data for this agency is the past cases they had, the past decisions they made, given a certain data situation from the start, whatever was their argumentation, and then we have the decision they made. So those data are past cases. And it is extremely important to have those input data for a system to train. And it's not important what algorithms you use, forget about this, but the feedback they received, that the human screeners were concerned with this particular interface that showed them how a similar case in the past was decided upon by this very particular agency. And I do not understand that they had these concerns, because whatever we as humans, we learn from the past, from our successes, from our mistakes. We are defined by our mistakes. So why ignore each and every decision of the past? And they tried to explain it that basing decisions about a current case on past cases that seem similar is discouraged, as this can lead to biases or self-fulfilling prophecies. Self-fulfilling prophecies are everywhere in our life. I don't get this point. I'm sorry. Please, if you have the solution, leave me a note in the comment to this video. I do not understand where this data set, where the machine learning algorithm was trained on, they do not want to have this information about the past decision they themselves made in the agency. Because, of course, the outcome of the machine learning algorithm is trained on their historic decisions. I don't get it. I don't get it why this was excluded. Yes, and then, of course, the model architecture, logics, the change in model performance if each factor is permitted individually, of course, the sensitivity on specific factors. But generally, the feedback was, hey, too much information might not be useful. If you're in the training phase, if you are learning about this, yes, but if you're 3 to 5 minutes, hey, too much information is overkill. And then the second model they had was this about model interface as the factor distribution explanation, which also gives a quick retrospective view. Of course, we have the data of the old decisions of how the model performed in the past. So what you do is you show them the old cases, the human decision, and how the model learned on those decisions and how the model would perform in the past, so that they get a feeling where the model would differ from human decisions. And there was interesting that they said, hey, those factor distribution interface shows too much information for use during our active decision-making phase from 3 to 5 minutes, which I understand, but gee, it is not easy to provide useful data to people who decide on such critical cases. And then we have here the user studies. When they had the prototype, they decided to run 2 formal user studies. So they have 2 groups of users. And the first group, of course, we have here our 12 data specialist, our data scientist, our social scientist, trained in user interface and whatsoever. And the second group was diametrically the opposite. They had those expert and child welfare screeners, those local experts in the community. And they constituted the second user for the second study group. And what I want to show you. We are all humans, and what they saw is that agreeing, if your personal judgment is A, and the model's prediction or decision support or decision augmentation data tells you also, hey, A, this increases the trust that you as a human have in the model the most. You think A and the model tells you, hey, A, you're right. You say, hey, now I start to trust this model. Could be deceiving, but of course, this is a human characteristics. And if trust was reduced when the opposite happened, well, of course. Information presentation, the data, what they learned was too many factors shown, 400 factors in 3 minutes, nonsense. The intercorrelation and interlink between 400 numerical factors is nonsense in 3 minutes. Confusion caused by correlated factors. If some factors are correlated, you don't need additional factors, so reduce the set as to the bare minimum. Confusion about Boolean terminology in the results. A screener does not know what Boolean operators are. If you give them as a result that the factor child has siblings, as a Boolean value of false, and this is the output of the system, they preferred a single display as child does not have siblings. Well, I can understand this. You know, this makes sense to me. Limitations. The general lessons learned. How augmentation tools can improve the usability of machine learning models in the child welfare domain. A highly critical domain. Extreme responsibility on the humans who decide this. And they stated that the users, the expert, wanted to receive information about the model, about the machine learning model in a language and in a format that mirrored their own. As I already told you, yeah, of course, if you have the Boolean operator is true, doesn't help them because they are not data scientists. They want to see, hey, this is the case or this is not the case. Forget about the Boolean operator for user-specific data presentation. Yes, then if the factors were confusing, not clearly formulated, not clear about the risk implications they have on the overall risk factors, of course. Cognitive biases, yes, of course. Representative bias, yes, of course. Risk encouraging users to make decisions based on similarities to other cases. I'm not so familiar. I have my problem with this sentence, but whatever. Of course, we have again here causation versus correlation, the age-old problem. Availability bias, yeah. Even the order you present the data, ascending order or descending order, may result in different decisions by humans. So there are so many usability factors when you design this prototype you have to take into account, you have to test, you have to work with the users who will really rely on the data the system presents to them. The form, the way they present the data, it is so important that it is intuitively clear that all the data presented are really of value for the human decision makers. So it's already 25 minutes on this study. And I know this is a very, very sensitive topic, but if you want really to learn about the importance and the significance, how we design prototype for decision intelligence or decision support or overall decision making, have a look at this study. Look at this in a case where it is so important that the decision intelligence gives its optimal best, that there's no mistake whatsoever if a machine learning algorithm presents a solution to the human decision maker. And again, it was not about the machine learning algorithms per se, if it's a deep learning neural network or if it's just a classical machine learning algorithm. This is not the point to this. This is independent of whatever the machine learning algorithm is. The way we present it, the usability to the user is so important from the system design. You could have the best algorithm in place, but if you present it in a way that is not integrated in the workflow, in the business processes of a company, all of this is for nothing, and you just do it for scientific whatsoever reasoning, but you do not provide added value to this particular user group. And with these thoughts, I would like to leave you, and I see you in the next video.